Hello everybody, I'm Stefanos Nicolaou, I'm from Cyprus, and I'm here to teach you all you need to know for the Alkali methods for the Edexcel International GCSE 921 examination. First of all, alkali metals are very reactive metals. They react rapidly with oxygen to produce metal oxides, so they are stored in oil. When we store them in oil, we avoid them coming in contact with oxygen, so they do not react with it. They are soft. We can literally cut them with a knife. If we take a piece of sodium and we can cut it using a knife, seriously. And they are very corrosive. We have to avoid contact with skin. The easier way to do it is to wear gloves when we want to do experiments with them and when we want to take them to touch them. The chemical properties of the alkali metals. They react with water to produce an alkali and hydrogen. Actually, when the reason we say they are corrosive, so we cannot touch them, when we touch them, they react with sweat that we have on our skin, on our hand, for example. The sweat is mainly composed of water, so they will react with the water, and that's why we say they are corrosive. They react with acids to produce salt and hydrogen. They react with oxygen to form metal oxide, and they react with halogens to form salts. They also form ionic compounds. The reason that all the alkali metals react in the same way is because they all have one electron in their outer shell, and the elements that have the same number of electrons in their outer shell, they have the same chemical properties. The reaction of alkali metals with water. This is the important reaction for the IGCSE, and the reaction that we have to know, because it is an easy experiment to do. Metal and plus water gives us alkaline and hydrogen. For example, sodium plus water gives us sodium hydroxide plus hydrogen. You have to be able to write both word equation and chemical equations. The observations when you do this, when this reaction is occurring, we have fizzing. Bubbles are produced because of the hydrogen. Hydrogen is a gas, and the gas always wants to escape from the liquid, isn't it? It wants to escape from the solution, so it escapes in the form of bubbles. The metal moves rapidly on the surface of the water. If you put a piece of sodium on water, it will start moving on the surface of the water as it reacts. It also dissolves. It dissolves because this reaction is exothermic. If you don't know what that is, we'll talk later about it. It means that heat is released, and this heat melts the metal. The alkali metals actually have a low melting point, and the heat produced by the reaction is enough to melt them. But lithium is the exception here. Lithium has a higher melting point, and it reacts slower, so the heat produced is not enough to melt it. The metal catches fire with air. This is not always the case with all the metals. For example, potassium, yes, potassium catches fire with air because it is very reactive, but lithium and sodium, they don't. And metal hydroxides are colorless solutions. Yes, always. For example, sodium hydroxide, potassium hydroxide, lithium hydroxide, they are colorless. The reactivity of alkali metals. The reactivity increases down the group. Okay, we have the periodic table here. We have lithium, sodium, potassium, rubidium, cesium, and francium. The reactivity increases down the group. So sodium is more reactive than lithium. Potassium is more reactive than sodium, and so on. This is why lithium has two outer shells because it is in the second period. Sodium has three outer shells since it is in the third period. Potassium has four since it is in fourth period, etc. The outer shell of lithium is the second one, while the outer shell of sodium is the third one. Okay, so when the alkali metals react, they want to become ions. They want to have a full outer shell. In order to do it, since they have just one electron in their outer shell, they need to lose that electron, to kick it away. To lose these electrons so that they have full outer shells. Lithium has two outer shells. The outer shell of lithium is the second one, therefore is closer to the nucleus. The outer shell of sodium is the third one. It is further from the nucleus, isn't it? Because it has three outer shells. The third outer shell is further away from the nucleus than lithium. And potassium, the outer shell of potassium, is the fourth one. It's even further away from the nucleus. In order to lose, for the alkali metals to lose an electron, there has to be an energy to overcome the attraction between the nucleus and the electron. Okay, then between the electrons are negative and the nuclei are always positive. So between negative and positive, there's always an attraction. The nucleus attracts the electrons. The outer electron of lithium is closer to the nucleus because it is in the second outer shell. It is in the second shell. While the outer shell of sodium is further away from the nucleus because it is in the third shell. I can also show it to you here. We have lithium has two shells. This is the outer shell of lithium. Sodium has three shells. This is the outer shell of sodium. It is further away. The attraction between lithium and the outer electron is stronger because since the outer shell electron is closer to the lithium, the attraction is strong. But in sodium here, the outer shell is here. It is further away from the sodium. So the attraction between the nucleus and the electron is weaker. I hope that this is clear for you because it is very important. I don't want you to panic. Do not learn by heart that the reactivity increases down the group. You have to know why. You have to know the reason and to be able to describe it. Lithium has two shells. The outer shell is closer to the nucleus than sodium that has three shells. The attraction between the nucleus and the outer shell of lithium is stronger. It's like you have, for example, you have a magnet. Let's say that your nucleus is a magnet and you have a metal ball. You place the magnet and you draw two circles around it. The outer electron of this is in the second circle, so it is close to the nucleus. It's close to your magnet. But let's say that we have sodium. You have your magnet. You draw three circles around it. So the third circle, the outer shell, is further away from your magnet. So if you put a metal ball there, the attraction between the magnet and your metal ball, it will not be that strong. Do you get me? Perfect. So the reactivity increases down the group. In order to react, the alkali metals need to lose an electron to form metal ions. As you move down the group, the atoms have more shells. The outer shell is further from the nucleus, so there is less attraction between the nucleus and the outer shell. Therefore, less energy is needed to remove this electron, since the force between the nucleus and the electron is weaker. The energy to overcome this attraction, and to lose this electron is less. Now, just a note here, the shielding effect. The shielding effect increases as the number of shells increases. The inner electron repel the outer electrons. So what I mean is, It increases as the number of shells increases. For example, sodium has 3 shells, while lithium has 2 shells. Sodium has more inner shells, more inner electrons, so it has more shielding effect. The shielding effect is higher. I hope you understand what I tried to say to you. The atomic radius is the distance from the nucleus to the outer shell of an element. And of course, it also increases as the number of shells increases. We'll see here, lithium has 2 shells, sodium has 3 shells. The outer shell of lithium is closer to the nucleus, while the outer shell of sodium is further from the nucleus. That's why sodium has a bigger atomic radius. You can also say, for example, while describing the reactivity of alkali metals, that it increases as the atomic radius increases. And ionic radius is exactly the same thing, but it is the distance from the nucleus to the outer shell of an ion. It's just a note here. Atomic radius is for atoms, ionic radius is for ions. Now, endothermic and exothermic reactions. This is also a node. I think that you already know it, but I just want to refer it. When the reaction is exothermic, heat is released and the temperature increases. What I mean, it's important to understand it and to remember it. Don't learn it by heart. It is exothermic. Exo in Greek means outside. And thermic in Greek also, it means temperature. Not temperature, it means heat. So heat is released. It goes outside. If you put sodium in water, which is an exothermic reaction, heat will be released, and the water, for example, it will boil. It will heat up. That's why the temperature increases. But endothermic reaction, endo in Greek means into, and thermic it means heat. So endothermic, heat is taken in and the temperature decreases. Just think it is something that wants to react, and it will absorb energy. It will absorb energy from the environment, so the energy of the environment will decrease. The flame test is a test that we do to identify some elements, for example, alkali metals. To do it, we dip a platinum wire in concentrated hydrochloric acid to remove impurities. It's important that we use platinum wire because platinum is inert. It does not react. We don't want our wire to react with the hydrochloric acid. Hydrochloric acid is an acid. Metals react with acids very strongly, but platinum does not react. Also, gold and silver do not react, but they are much more expensive than platinum. Then we will dip the platinum in our testing sample. The testing sample will contain the element or the alkali metal that we want to identify. And we will take a Bunsen burner. We will turn on the flame and we will place the wire in the flame of the Bunsen burner. Now, what will happen? The flame will change color, and each color indicates the presence of a specific element. If we have sodium ions in our sample, then the flame color will become golden yellow. If we have potassium, it will become lilac. If we have lithium, it will become red. Now the rest are not alkali metals, but I have to refer them, I think, because you have to know them for the examination, for the flame test. Yes, they are not alkali metals. I don't want to have another lecture about them, so I will refer them. For the calcium ions you have a orange-red flame, copper ions a blue-green flame, strontium crimson-red, barium apple green, and magnesium, you'll see a very bright light. Actually, the energy emitted by the burning of magnesium is out of the visible spectrum. So we just see a very bright white shine. Actually, it's not white. It's something that we cannot see. It's not in our visible spectrum. Just a bright light. Okay, of course, you don't have to explain this in the examination. Just say white, and it's okay. Okay, don't panic with all these colors. Yes, you have to know them. Try learning one or two every day, but if in the exam, for example, you have the strontium and you forget crimson red and you just remember red, it's okay, say red. It's still correct. But I prefer that you know that these little details like crimson red, orange red, because maybe they will ask you in some exercises to identify between strontium and lithium, for example, and you have to know that lithium is red and strontium is crimson red. Okay, so that it was for today. I hope that you learned something new today. I really hope that I helped you to understand better the alkali metals. Actually, this is all you have to know about the alkali metals chapter. If you have the book Edexcel International GCSE 921 Chemistry, it's good to read from the book that chapter, but you'll just find there more details. I think that if you know these things, this is all you have to know. Okay, I'm Stefanos Nicolaou. I'm from Cyprus, and I hope I helped you. Thank you. See you next time.